Okay, thank you very much. Thank you very much for the invitation to your conference and to beautiful Lucca. It's a very lovely place and I look forward to seeing a bit more of it tomorrow. I'm Keith Redway. I'm from the University of Westminster, and since 1993 with colleagues I've been doing studies on different hand drying methods, comparing them. We've also been doing observations on people in real toilets, in real washrooms. So it's a long time I've been investigating them. I've worked for various paper organisations, but I've also worked for the people who make textile roller towels, because the university is meant to be impartial. I've never been asked to work for any electric dryer companies. And the reason for that probably is that in every test that we've ever done, we've always found that towels, that's either paper or textile, perform much better in pretty well every test that we've done. So they've never asked us to do any work, and maybe it's not surprising. Our latest studies have been sponsored by the European Tissue Symposium Brussels. We did one in 2008, which is on their website. But the basis of that really was that we were testing the jet air dryers, which in previous studies, jet air dryers hadn't existed. And we tested the efficiency of the different hand drying systems, so it's paper towels, textile towels, the warm air dryers that we're familiar with, plus a jet air dryer. And it backed up a lot of our previous studies. Paper and textile towels were very efficient at drying. Warm air dryers weren't, they were slower. But the jet air dryer was as fast as towels. Now, based on that, I'm a microbiologist. I thought that then the jet air dryers would perform pretty well on the hygiene side. But in fact, we were quite surprised to find that they didn't perform as well as towels. They did not reduce the bacterial, the microbial count on people's hands after they'd used them at all. In fact, there was a slight increase, whereas towels always reduce that count. This is average for many subjects. Warm air dryers were the worst of the lot in that respect. We did some other tests as well, where we looked to see if a dryer or drying device, paper, towels, whatever it might be, if it could spread material, contamination from people's hands. And for that we used a harmless yeast model. We couldn't hardly coat people's hands with bubonic plague or something, but we used something harmless, food yeast, and we were able to detect yeast at quite large distances from jet air dryers. Up to 2 meters we were detecting yeast that had been on people's hands artificially there, and it was dispersed, it was being transferred. So that was interesting. We also looked at the contamination of the surfaces of jet air dryers. We used ones in a busy railway station in London, near where I work, and we found quite high levels of contamination on the inner surfaces, which people may touch. In our observations, people do sometimes touch the inner surfaces of jet air dryers. So this public perception that the previous speaker was talking about, that some electric dryers are very hygienic because it's air and people don't touch them, it's not actually strictly true. And also air is a means of transmitting microbes, contamination and possible disease-causing organisms. So that was our previous study, and I want to now introduce you to some newer stuff that we've done. So we compared the 4 different hand drying methods. We used paper towels for 10 seconds. The 10 seconds is based on previous studies of ours. It's about the average that people, certainly in the UK, use in public washrooms, about 10 seconds. We use continuous roller towels, the textile towel. Similarly, it's about 10 seconds. It's a nice round number. We use the warm air dryers for 20 seconds. It varies a bit. It's between 20 and 25 seconds that people use them. Ladies sometimes use them a bit longer than men in our experience, but we set it at 20. That's based on the fact they're slower anyway. Most people give up after about 20 seconds anyway. And then we based the jet air dryer one on manufacturers' recommendations that they should dry the hands in 10 seconds. So we split this study into 4 parts. I'm not going to bore you with a lot of facts and figures, but I'll just take you through the main findings. First of all, we looked at the amount of water that was removed from the hands of users when they were drying their hands using these 4 different hand drying methods. So we actually measured the amount of dryness, or the amount of water that was retained on the hands. And what we found was that based on those times, those set times for towels and for warm air dryers and jet air dryers, that the percentage dryness, 100 being the maximum of course, that paper towels, continuous roller towels and jet air dryers were all pretty much the same. They produce roughly 90% dryness. In other words, it was 10% of the moisture, water was still there. But the warm air dryer was much worse, and that backed up previous studies that we'd done, although we hadn't ever looked at the jet air dryer in our previous studies. So we've got three methods that are pretty much the same in terms of drying efficiency, and the warm air dryer is a long way behind. But then we wanted obviously to look at other aspects. So that's percentage dryness after using 4 different types of hand drying device. So our conclusion is pretty simple really. The warm air dryer was considerably less efficient and slower at drying the hands in normal use. If you spend 2 minutes under one, your hands will probably get rather uncomfortable, but it will dry them better. But this is based on normal use, average use by a member of the public. Okay, part 2, we looked at the potential for the transmission of contamination on the hands of users. In this part, we used I came up with this rather strange idea. People actually wash their hands in lemon juice, and lemon juice is acidic, and it was then we detected the presence of the lemon juice if it had been thrown away from the dryers using indicator paper. So it's a bit like litmus paper that you might have met at school chemistry. This wasn't litmus paper, but it changed colour if something acidic went on it. And we use lemon juice because it's harmless, pretty well harmless. This is one set of experiments where you can see a jet air dryer on the right there, and these paper discs are the indicator papers, and they're laid out to see how far the lemon juice that's on people's hands would be transmitted, and that would also equate with how far any contamination on people's hands would be transmitted perhaps to other people or within the washroom environment. We also, in this later study, did this. We had this board, and you can see a whole family there. There's mum, dad, and a little child, and they're painted onto the board, and the board is completely covered in this sort of yellow indicator paper, but when lemon juice lands on it, it goes pink. And you can see again a jet air dryer. But all our tests were done on all 4 methods, and they were all treated equally. This is one of our researchers, Sheila, using a jet air dryer with the indicator papers in the background. I'm just hoping this is going to work. Stop, please. Yeah, I think I will stop it. You can see that Sheila's wearing goggles. This is to protect her eyes from any lemon juice, but she's not wearing ear defenders. And we all know, I think, that type of hand dryer is extremely noisy. So she should perhaps, from a safety point of view, used ear defenders. This is the board after that sort of experiment, and it's peppered with lots of little droplets of lemon juice, which have then produced this pink colour. And then we examined the boards in detail and counted the number of spots at different heights. We were particularly interested to see whether a child standing near one of these dryers was particularly prone to contamination, perhaps from their parents who were using the machine and perhaps hadn't washed their hands very well, their hands were still dirty. And you can see complete spattering of droplets all around this. This is from the child's figure here. This is with a jet air dryer. With the paper and the textile towels, we got virtually nothing. Just a few spots, usually lower down, really very little at all. And actually our warm air dryer didn't produce results that were too bad. We have not a particularly high-powered dryer, so that might explain it. But we know with that type of jet air dryer, they throw out air at very high speed, so over 500 kilometers an hour, so it's not surprising they can throw lemon droplets a long way as well. Okay, so that's one model, lemon juice model. We then thought, well, we can't just work only with lemon juice, we better work with some proper microbes. We couldn't work with anything too pathogenic, but we worked with yeast, just like we'd done in our previous study. And again we had the board, but this time instead of an indicator paper covering, it had agar plates, a jelly that will grow any yeast that lands on it. And this is a rather typical result of using a jet air dryer. You can see it's splattered, and little tiny droplets containing the yeast will grow up into these colonies. We didn't get hardly anything with the other drying methods, certainly not with the paper towels. Okay, so we had two models, yeast, and we had the acid model. Then we thought we'd better look at real organisms on real people's hands. So we didn't artificially contaminate their hands with lemon juice or yeast. We just asked them to use these devices in the normal way. And we had various types of agar. This is actually blood agar in the background. It's horse blood, and it's a very rich medium. It will pick up virtually anything that lands on it and detect it and grow it. Similarly, we set up the same board near a cloth towel, a textile towel, and also near a paper towel dispenser, as you can see there. And these are just some typical results from a jet air. Again, we got most of the colonies, most of the growth, most of the evidence of transmission and contamination from the jet air dryer. It didn't surprise me. Microbiologists know that air will transmit microbes, potential contamination. This is actually blood agar, quite a lot of colonies there. Remember, those could have gone onto somebody's face, or they could have inhaled them. That's what they're demonstrating. Here's another blood agar plate, and there's quite a lot of hemolysis here, breakdown of the red blood cells, which is sometimes a sign of certain types of pathogen. We weren't able to identify absolutely everything, and that's just a close-up of that type of colony. This last one is a different type of medium, and it can show up Staphylococcus aureus, which includes MRSA, which I think many of you will have heard of. It's a big problem in hospitals, hospital-acquired infection. And if it goes yellow around the colony, that's a sort of a presumed identification of Staphylococcus aureus. So what we're showing here, this is from a real person's hands using a jet air dryer, is that what was on their hands, Staph aureus, could be MRSA, particularly if they're in a hospital, has actually been transmitted off their hands and onto the figure, the plate on the figure. In other words, showing the potential to contaminate, possibly infect other people. Okay, so the conclusions for those three parts 2, 3 and 4, the jet air dryer without doubt showed a greater potential for the transmission of contamination on the hands of the users at varying distances and at different heights than the other three hand drying methods. The towels, both types of towel, showed very little transmission at all. This is I've just put at the bottom here, a study that we actually did in public toilets many years ago, when we looked at nearly 300 persons in public toilets in London. So I used to lurk around toilets, and so did my colleagues, without getting arrested, hopefully. Surreptitiously observing people, whether they washed their hands, how long they spent on it, whether they used soap, how they dried their hands, that sort of thing. And just a pinpoint of information out of that was that 68% of the users of public toilets who washed their hands, over half didn't actually use soap. So they weren't actually washing their hands very well at all. And that figure was slightly worse for ladies than for gentlemen, possibly because, I'm being a bit sexist now, they might have thought that soap would make their hands rough, but you often saw people just using water, very cursory, so they can tell themselves that they've washed their hands, but in fact they haven't washed them adequately, not at all well from our point of view. Okay, this is the last part of that study, where we tried to visualize this transmission, this movement of air from the hand drying devices and the potential transmission that could occur in that process. This is me using some paper towels, and we had, this is carbon dioxide, solid carbon dioxide and water vapour. But you can see there's very little disturbance of the air in this case, pretty much what we'd expect. And most of it's downwards, it's not to the side into somebody's face, so it's relatively safe. This is a similar one with a textile towel. This is our laboratory in London. That's me again, and you can see There's an awful lot of water vapour bubbling up there, but there's very little spread of it. Most of it's just downwards because it's heavy. It's not really being spread by the movement of the dryer. This is a warm air dryer, to me yet again, and you can see there's much more spread. We would expect that because it dries by evaporation and air movement, but it's not anywhere near as bad as the last example I'm going to show you, which of course is a jet air dryer. Most of it again is downwards. These things generally blow downwards. So again, not as good as the towels, but certainly better than something that blows stuff out the side. That's enough of that. This is the jet air dryer. You can see there, it's almost like an explosion of stuff goes everywhere. And if somebody's got dirty hands, they haven't used soap, they haven't washed their hands properly, they're just a mucky person, anything that's on their hands is going to be blown off and distributed all around the washroom, right into people's faces, right to the person standing next to the dryer, the next dryer, onto a child that perhaps is watching their mother dry their hands. So this perception that these things are very hygienic because they use air, you don't touch it, is, to our mind, quite false. The public needs to be disabused of that idea. So our conclusions, due to their airflow, the electric dryers, both types, showed a greater potential for the transmission of contamination on the hands than the towels. Thank you very much.